C. We can paste this here again. We can get rid of all the other conditions. Port 3 is short-circuited. And all other ports. So what is the reflection coefficient seen at port 1? So this one, port 3 is short-circuited. All other ports are terminated with match load, so V4 minus is 0 and V2 minus is 0. We have a signal coming into port 1 and a signal coming out of port 1, right? We can call this V1 plus, V1 minus. Short-circuited means, okay, we look at we look at gamma, which is ZL minus Z naught over ZL plus Z naught. Short circuit means ZL is 0, 0, 0. This is equivalent to minus 1. We know that the reflection coefficient is equivalent to V0 plus V0 minus over V0 plus, which is equivalent to V0 minus equivalent to reflection coefficient V0 plus. Since the reflection coefficient when ZL is 0, the reflection coefficient is minus 1 when ZL is 0, meaning short-circuited case. V0 minus is equivalent to minus V0 plus. Okay, so for the short-circuited case, V3 minus is equivalent to minus V3 plus. We can get rid of all this here. And we can also draw a signal coming into port 3, V3 plus, and then a signal coming out of port 3, which is V3 minus. Right, so what is the reflection coefficient seen at port 1? Okay, so here we can have V1, we can have S11, we can have S33, we can have S13, or we can have S31. This is equal to V1 minus over V1 plus. This is V3 minus over V3 plus. This is V1 minus over V3 plus. And this is V3 minus over V1 plus. This S11 V1 minus is equivalent to S11 V1 plus. V3 minus is equivalent to S33 V3 plus. V1 minus is equivalent to S13 V3 plus. And V3 minus is equivalent to S31 V1 plus. The reflection coefficient seen at port 1, right? The reflection coefficient at port 1 means we're looking for port 1. Okay, what is the reflection coefficient seen at port 1, right? So reflection at port 1, we have the reflection coefficient, which is V1 minus over V1 plus. We introduce V1 and we measure how much V1 minus is reflected, how much we have of V1 minus. So here we can see that V1 minus occurs twice, one from S11 or from V1 plus and one from V3 plus. So V1 minus is equivalent to this V1 and this V1. So we have S11 V1 plus S13 V3 plus. We know that V3 plus is equivalent to minus V3 minus from this when we have a short-circuited case. V3 minus is equal to minus V3 plus, and we can also say that V3 plus is equivalent to minus V3 minus. So in this case, minus V3 minus is equivalent to minus S31 V1 plus. So we have V1 minus equal to S11 V1 plus S13 minus S31 V1 plus. This is equivalent to S11 V1 plus minus V1 plus S13 S31, which is equal to V1 plus quantity S11 minus S13 S31. We can get V1 plus to the left-hand side, so we have V1 minus over V1 plus equivalent to S11 minus S13 S31. We know that S11 is equivalent to 0.178 at an angle of 90 degrees. S13 is equivalent, what's S13? S13 is equivalent to 0.4 angle of 45 degrees. 0.4 at an angle of 45 degrees. And then S31 S31 is 0.4 at an angle of 45 degrees. 0.4 at an angle of 45 degrees. So this is 0.178 angle of 90 degrees minus 0.4 angle of 45 degrees times 0.4 at an angle of 45 degrees. So we can add the angles and multiply the magnitudes. So this is really just saying 0.178 J 0.178 minus when we have 45 plus 45, that's 90. That leaves us in the J axis. J 0.16. So V1 minus over V1 plus is equivalent to J 0.018. So V1 minus over V1 plus is equivalent to 0.018 at an angle of 90 degrees.